Okay, let's give a quick proof that this is convergent. And I'll use the idea of absolute convergence. Okay, so let's see. If I look at summation of absolute value, and you get summation 1 over n cubed. Okay, the minus 1, if you have minus 1 to the n, and you do absolute value, okay, you just get 1, right? Because this is plus or minus 1, and in either case, it's just 1. Okay, now this guy, this is convergent since p is equal to 3 is greater than 1. Therefore, the original series is absolutely convergent, is absolutely convergent, AC, absolutely convergent. So again, AC stands for absolutely convergent. And if a series is absolutely convergent, it is necessarily convergent. Okay, so that's a relatively quick proof. I think it's a bit shorter than if you were to use the alternating series test. Not a big difference, but anyways, gives you some options, gives you some more tools. So we'll see later that this tool, this kind of technique here is useful in situations where the alternating series test is not useful. Okay, let's return to an example we did. This guy. This is C, it's convergent, but not absolutely convergent. Okay, we saw this before. Okay, it's convergent. Why? Because, well, you can do alternating series tests. And you'll quickly see that it's convergent. But if you consider the series of absolute values, you're going to get this harmonic deuter, and that is divergent because P is 1. Okay, so this is a special kind of guy. We call it conditionally convergent. So we'll use that as a definition. Okay, so if you have something that is convergent but not absolutely convergent, it's called conditionally convergent. So conditionally convergent if it is convergent but not absolutely convergent. So that's what this guy is. So we'll say that up here. It's this guy up here is it's conditionally. So that was the significance of this little bit here. Now, what does this do for us? This definition. Well, it gives us a way to categorize all series. So we're going to see that all series fall into, every series falls into one of three categories. So let's say, okay, all series Okay, they are either let's use the acronyms here. They are either divergent or convergent, right? So we'll do a little tree diagram. Every series is either divergent or convergent. Okay, it's got to be one of the two. Now, if it's convergent, here's where things get a bit more complicated. Now, let's say it's convergent, but not absolutely convergent. Well, then we say it's conditionally convergent. So conditionally convergent. Okay, the acronym is CC commonly. So inside the category of convergent series, you have conditionally convergent or absolutely convergent. So for convergent, what are we saying? We're saying that the original series converges. Okay, that's here. Now for AC, we're saying that the series of absolute values also converges. And for CC, we're saying that the series of absolute values does not converge, like in this case. Okay, so useful to keep in mind that every series that you encounter will be in one of these three categories. Desmond has a Molly has a barrow in the marketplace. Desmond has a market in the barrow place. Molly. Desmond has a marrow in the oh-blah-dee, oh-blah-da, life goes on, la 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 la, life goes on.